Solve the equation 3 sine 2 theta tan theta equals 2 for theta from 0 to 180 degrees. The concept for solving these equations is always the same. We need to change the whole expression so that there's one trigonometric term, either one sine or one cos or one tan. Then we can always do the inverse sine or inverse cos or inverse tan to find the value of theta. So we need to use the trigonometric identities to turn sine 2 theta and tan 2 theta into some form of one trigonometric function. According to the formula sheet, there's only one identity we can use with sine 2 theta, which is sine 2a equals 2 sine a cos a. For tan theta, there's only one identity we can use as well if we choose to use it. Tan theta equals sine theta over cos theta. If we try using both identities to replace sine 2 theta and tan 2 theta, we get 3 times 2 sine theta cos theta times sine theta over cos theta equals 2. And you can see that the cos will cancel out, leaving only sine functions. We are now one step closer to getting the answer because now we have the expression as only one trigonometric function, which is sine. The next step is to make sine the subject of the formula. And we do this so that once we have sine theta as the subject of the formula, we can find theta by just doing inverse sine. Once we have sine squared theta equals 2 over 6, to make sine theta the subject of the formula, we need to square root both sides. And don't forget that whenever you square root, the positive answer works and the negative answer works as well. So we have sine theta equals plus and minus the square root of 1 over 3. This means that we can find theta for sine theta equals 1 over root 3 and sine theta equals minus 1 over root 3. So we have to do the inverse sine twice. So now we have theta equals 35.3 degrees and theta equals minus 35.3 degrees. Every time you do inverse sine, inverse cos, or inverse tan, there could also be other values or other angles that give the same sine, cos, or tan value. So whenever we do this, we need to check the domain of theta to see if we can find the other angles as well. The domain of theta for this question is 0 to 180 degrees. There are two methods we could use to solve for the other angles that give the same sine, cos, or tan value. One of the methods is to look at the graph of the trigonometric function. In this case, we will look at the sine graph. We are looking for angles that give sine theta equals 1 over root 3. If we go to 1 over root 3 on the y-axis, draw a line, and it should hit the graph at the point corresponding to 35.3 degrees. But then if we extend the straight line to hit the graph again, it will hit the graph at another angle as well, and this angle should be 35.3 degrees from 180 degrees because the graph is symmetrical. Therefore, that angle must be 180 degrees minus 35.3 degrees, which equals 144.7 degrees. And we have to do this for sine theta equals minus 1 over root 3 as well. So using the same method, if we go to minus 1 over root 3 on the y-axis, and we extend the graph a bit to the negative side and draw a straight line and touches the graph, that point corresponds to 35.3 degrees. And then if we draw another straight line in the positive x direction, it should hit the graph again at the point over here, which should be 35.3 degrees from 180 to the right. So therefore that angle equals 180 degrees plus 35.3 degrees. However, the domain for theta is 0 to 180 degrees. Therefore, that angle is not in the domain, and neither is minus 35.3 degrees. So we don't have any theta values that correspond to sine theta equals minus 1 over root 3 within the domain. The other method we can use to find the other angles within the domain is to use the unit circle. The first angle, theta, equals inverse sine of 1 over root 3, which equals 35.3 degrees. So it's over here on the unit circle. And this is a positive sign. So therefore, the other quadrant that has a positive sign is the second quadrant. So we can draw another angle, 35.3 degrees, in that quadrant. And angles are always measured anti-clockwise from the positive x-axis. Therefore, the angle that corresponds to that line is 180 minus 35.3 degrees, which equals 144.7, just like we got from using the sine graph. If we do the same for sine theta equals minus 1 over root 3, theta equals inverse sine of minus 1 over root 3, which gives negative 35.3 degrees, which would be 35.3 degrees clockwise from the positive x-axis. And this is a negative sign, so the other quadrant that gives a negative sign would be the third quadrant. So we draw another 35.3 degree angle in the third quadrant. And the other line, measured from the positive x-axis, anti-clockwise, would be 180 plus 35.3 degrees, which is exactly the same as we got from the sine graph. However, both lines are not in the range of the domain because the domain is only from 0 to 180 degrees, so we don't have any solutions from sine theta equals minus 1 over root 3, and the only solutions we have are theta equals 35.3 degrees and theta equals 144.7 degrees from sine theta equals 1 over root 3.